Hi, what is on the workbench today is a ToolTop ET829 scope meter. Now, the market is getting a little bit crowded for these handheld oscilloscopes, and I have reviewed quite a few from Handtech and O1, and those are some of the more popular videos on this channel. I'd recommend you check those videos out as well if you are in the market for a compact scope meter. Anyway, I believe the ET829 is a relatively new model, and Banggood just sent this in for me to take a look. As usual, I will include a product link in the video description below for those who are interested after watching this video. Spec-wise, it has a 6000 counts multimeter built in, along with an 80 MHz bandwidth oscilloscope and a waveform generator. So the functionality is largely on par with the Handtech 2D72 and O1 HDS 272S. Now, the sampling rate of the built-in oscilloscope for the ET829 is somewhat lower. It is spec'd at 200 megasamples per second instead of the 250 megasamples per second found on either the Handtech or the O1. Of course, we will test it out later in the video to see if the 80 MHz bandwidth spec'd for this scope is accurate. Similar to a lot of Chinese products, it's very likely that the ToolTop is just one of the brands the ET829 is selling under. So if you take a look at the case and the product manual, you will see that the brand name is nowhere to be found, but only the model number, ET829, is shown on the product box here. Otherwise, this product manual and the box looks rather generic. So I assume if you see an ET829, regardless of the brand, it will be similar, if not identical, to the unit we're reviewing here. Now I have put the ET829 along with the O1 and the Handtech scope meters. You can see that their overall dimensions are largely identical. Obviously, the O1 has a 3.5-inch LCD, and the other two have smaller 2.8-inch LCDs. The front panel buttons layout of the ET829 is quite different than that of either O1 or Handtech, and I have to say, it looks quite modern. On the side of the ET829, we can see there is a USB-C port used for charging the device. By the way, the battery life is spec'd at around 10 hours for continuous use, which is quite impressive. But it appears that the USB port is for charging only, and I don't believe there is any PC connectivity like the O1 or Handtech, as it was not specified in the product manual. When plugged into a PC though, the ET829 does enumerate as a USB device, but it doesn't show up as a mass storage device. So if PC connectivity is something you must have, you probably have to look somewhere else. From my personal experience though, I haven't really had the need to connect to a PC for a handheld device like this. That said, I do want to point it out in case this is something important to you. Now let me power it on and take it for a spin. To turn on the device, you press and hold this power button. And you can see that the device actually boots up relatively quickly, and it defaults to the multimeter mode. To switch mode, you can simply just press either of these channel buttons to enter into the oscilloscope mode. Of course, that's channel 1 or channel 2 or both. Or you can press the AWG button to go to the function generator mode. The ET829 doesn't really retain your last operation mode, and it will always boot into the multimeter mode. So let me demonstrate here. So now I'm going to press hold the power button. It will simply power off. And now let me power it back on again. You will see that it will actually boot back into the multimeter mode instead of the function generator mode we were in before we powered off. Now, I'm sure this behavior could easily be updated via software to store the last power on state if the manufacturer chooses to do so. Since we're in the multimeter mode, let's quickly run through a few tests. As mentioned earlier, the built-in DMM has a resolution of 6000 counts. Now, that is not exactly high resolution. The O1 HDS series has 20,000 counts in multimeter modes, for example. But this resolution should be sufficient for most of the electronics work. Let's first take a look at the DC voltage measurement mode, as I have an EDC voltage standard up there and it's already powered on, as you can see here. And we can use that to test the DC measurement accuracy of this meter. Okay, 1 volt, 2 volts, 3, and no problem at all, as you can see, is spot on. 4, 5, 6, and because it's a 6,000 counts meter, I would expect we're losing 1 digit if I increase to 7, 7, yep, 8, 9, 10. As you can see, no problem at all. And now let's take a look at the millivolt range, because we are able to discern the last digit here. So let's take a look. And I'm going to dial in 1 millivolt, 2 millivolts, 3 millivolts, 4, 5, 6, 7, 8, 9, 10. So you can see that even the millivolt range is pretty accurate as well. Now I changed the voltage standard back to 6 volts, and we're currently in auto ranging mode. I'll show you the manual ranging capability here. To manual range, I just press this auto button here. Now you can see we're in manual ranging mode. Now we're measuring 60 volts, 600 volts, and 1000 volts. No problem at all. And to get back to auto ranging mode, I just long press this auto button. Wow, the beeping sound is really annoying. So let me actually turn it off here. So I think I just come here, beep, I can turn it off. Yeah, so now we should be quiet now. Yep. Another feature that is unique to this meter is the ability to be able to store data points. So I'll show you that. To store data, we can press menu, and you can see we have data. And then we have all these data points. So let's go back here and I'll show you how it works. To store data, we just press the save button. And now that data point is saved. We can, of course, press another one, and we save another data point. Later on, if you want to check the data points you saved, you simply go to Menu, and the data, you can see that we have the 2 data points saved there. And let me just zoom in. You can see that's 6 volts, 6.002, and 003. So that can potentially come in very handy when you are doing some kind of measurements. You wanted to figure out what exactly the data points was before. And now, of course, we can just clear all these. So that's the capability I wanted to point out there. Another feature that's unique I found quite useful on this meter is this ability to hold the display. Now, holding is actually not something new. Any meter has that functionality, but this one, what is unique is once you hold the current reading, you can see that you have a smaller window here that shows you the actual live reading of the measurement you are trying to do right now. So right now, for example, it's showing 6 volts, and if I change that reading, you can see that is updated to 5 volts. So that is actually very handy, as you can temporarily freeze the previous reading while dynamically still observing the current voltage reading or whatever measurement you are currently doing. So that is very neat. Now, the one thing that you'll need to pay attention is that while you are in this mode, you notice that we're actually frozen to a specific range, which means if I increase the input voltage in this case, you will see that it's over the range. And even if I go back to the dynamic measurement mode, it's still retaining that 6 volts range. So that's something to pay attention to. Of course, I can always just press and hold this range button, and it will automatically change it to the correct range. Next, I wanted to take a look at the current measurement capability of this meter. Now this time I'm going to change things around a little bit. Instead of measuring my current standard, I'm just going to use the other 2 meters as reference here. The BK Precision here is a 6,000 count meter. This is similar to the meter we're using here, and the Unity UT61E Plus is a 22,000 counts meter. But first, let me change the measurement mode of the ET829 to measure current. And you can see that actually it's very nice. We have this indicator telling you where you need to plug in your probes. And of course, right now we're in current measurement mode. That's the middle two plugs here. And you can see we have set it up correctly. Anyway, let's start ramping up the current. You can see, wow, I did not notice that the first stop is 666, but you can see that is matching fairly well. And let's keep increasing. No problem so far. Let me just increase all the way up to 100 milliamp and see what we got here. It seems that both the BK precision and the unit T meters are tracking pretty well with respect to each other, but the ET829, the reading is a little bit off. Now, believe it or not, that's actually still within spec. If you look at the specification, it tells you the DC current is essentially 1.2% plus 10 digits, so that is definitely still within spec, so no problem at all. As I have demonstrated a little bit earlier, both the voltage readings and the current measurements are actually pretty decent, and also the update rate is fast enough. The resistance range is spec'd at 1% plus 5 digits. So let's take a quick look here. First, let me zero out the meter here. And you can already see that the range switching is not that fast, but that's quite comparable to the other scope meters we have seen so far. Now, this is already at 0, but in case you need to route it out, all you need to do is press this button here. So you can press it. That actually sets a relative measurement here. Now, of course, this is 0, which is good enough. Let's measure a 100 ohm 0.1% resistor. And let's take a look. You can see that it's roughly bang on. And by the way, the reason it's jumping a little bit is because the leads, if you look at it, these are not gold plated, so sometimes it doesn't make a very good contact. So 99.8 is actually essentially pretty bang on because we have that plus 5 digit specification here, so that's really not an issue. One thing interesting is that as soon as we set the relative, you see that the range actually is fixed. That makes sense actually, because you only want to use the relative reading when you are in the lowest measurement range. So now let me clear that so we can set it to measure auto. I think I just hold and press this button. Yep. So now it's auto. And let's measure another resistor just to take a look. So this is a 1 meg ohm resistor roughly. Let's take a look here. You can see that the measurement speed is relatively, it's okay. It's not the fastest, but it's certainly not the slowest. Next, let's take a look at the capacitance measurement mode. And by the look of it, it seems that we're currently at the lowest range. And if you look at the spec, you will see that the minimum resolution is at 1 picofarad. So let's measure a 100 nanofarad capacitor. And now, I think the reading of this one is actually a little bit lower than 100. That's the one that I've been using for this kind of test, but let's take a look. Well, you can see that actually the speed is relatively fast. So that's actually good. But we do just register 72 nanofarad, so let's take a look using the unit T to double check what the reading actually is. And let's see. Yeah, so it does look like we're measuring the correct reading. In fact, the update rate on the ET829 is actually faster than the unit T, so which definitely is a good sign here. And just for good measures, let's measure a large capacitor. This one is a 1200 microfarad capacitor. So let's take a look here. And now, so it does take quite a bit of time to actually register this capacitor. You can see that. The range is changing. And eventually it did measure the 1.2 millifarad capacitor, but it took quite a few seconds. Now, this is actually quite normal on a lot of these meters. The issue here I'm having is that it doesn't tell you whether or not it's actually being measured. So sometimes if you are not very patient, you could have thought, okay, is not registering, but you just have to wait a little bit longer for the readings to stabilize. Now I wanted to take a look at the frequency response of the AC voltage measurement range. And to test that, right now we're outputting a 1 volt RMS signal. It's a sinusoidal from the UTG-962E signal generator. So what I'm going to do is I'm going to gradually increase the frequency till it drops to roughly 0.7 volts. We'll get what the frequency bandwidth is on this ET829. So let's increase the frequency. And right now we're at 1 kilohertz. And you can see we don't have any voltage drop yet, so I'm going to keep increasing the frequency here. So you can see we already started dropping. Let me just rewind it a little bit to see when we started to seeing that frequency drop. So roughly at about 1.5 kilohertz, that's where we started seeing the frequency drop. You can see that on the UT61E, we don't see that frequency drop, as this one actually has a much higher frequency bandwidth here. So let's keep increasing. And you can see that we're dropping really quickly. Right now we already dropped under. So right now we're at about 3.1 kilohertz. So let's take a look here. You can see that the input frequency is at 3.1 kilohertz. And therefore we have a bandwidth of about 3 kilohertz for this ET829 for AC voltage measurement. Now I'm actually a little bit curious to see if the frequency measurement can pick up that frequency here. So let's change it to hertz. And you can see that we're actually showing the 3.1 kilohertz roughly. So let's keep increasing that. Actually, let me drop it back to 3 kilohertz. And we're just going to increase the most significant digit, 4, 5. And you can see that no problem at all. Now, according to the manual here, you can see we have a frequency range of between 9.99 hertz all the way to 10 megahertz. And the voltage is no less than 1 volt peak to peak. So right now we're at roughly 2.8 volts peak to peak. So let's increase the frequency and see at what point we're not able to measure that frequency anymore. 9, 10, and we'll do 10 kilohertz at a time. 20, 30, oh, hang on. So it seems like 20 kilohertz we're okay, but at 30 kilohertz you can clearly see that we're not able to pick up that frequency. And let's do 40. Nope. So it looks like somewhere in the 20 kilohertz is not able to pick up anymore. Now let me increase the amplitude. So right now we're at, let me just see here. If I increase the amplitude, it is a little bit better, but it's still not able to pick up the full frequency. Right now we're at about, let's see here. Let me just increase to the maximum here. And we're at 30 kilohertz. And I'm going to go back to the frequency and we'll keep increasing. 40, 50, 60, 70, 80. Yeah, we're okay. And right now we're actually at about 20 volts peak to peak, which is clearly much larger than the 1 volt peak to peak. But let's keep increasing the frequency. So frequency, let's do 200 kilohertz, 300, 400, 500, 6, 7, 8, 9, 10. So it's 1 megahertz. Let's go to 2 megahertz, 3 megahertz. Nope. It seems the maximum here is just above 1 megahertz. You can see that 1 megahertz, we're able to measure it. And at, let's just see at what point here, 1.1. 1.2, 3. Yeah, so it's pushing it. So just about 1 megahertz we're not able to measure anymore. And this is actually at about 20 volts peak to peak. So clearly we have some issue with this frequency measurement here. As you can see on the manual here, we should be able to measure between 10 hertz to 10 megahertz with a input signal amplitude of 1 volt peak to peak. But right now we're at 20 volts peak to peak and we can barely measure 1 megahertz. And let's actually go back to the amplitude of a 1 volt peak to peak and see what realistically we can measure on this ET829. Okay, so it seems that we're able to pick up a 6 kilohertz signal with 1 volt peak to peak. Now, we probably won't be able to pick anything higher than that. So 7 kilohertz, for example, yeah, you're getting a lot of errors here, and the 6 kilohertz seems to be the highest we can get. So clearly the AC measurement range is way off, according to the spec, as it's nowhere near that 10 megahertz that we can measure. Even with the input signal up to 20 volts peak to peak, we were only barely able to measure 1 megahertz. So now a few days later, I did send an inquiry to the manufacturer regarding the issue I saw in the frequency measurement. And they acknowledged my findings and said they were going to update the spec sheet in the future. So we'll have to see when that is updated. But in the meantime, please keep in mind that the frequency measurement is not anywhere near what is claimed on the spec sheet, and is only useful for measurement up to several kilohertz. And you can probably measure up to 1 megahertz if the input amplitude is significantly higher. Now for completeness, let's test the accuracy of the AC measurement of the ET829, comparing that to that of the UT61E+. For that, I'm hooking both meters to a variac, and let me increase the voltage, and we'll see what we see on both of these meters. And you can see they're largely identical to each other, and the update rate on this ET829 is actually not that bad. So let's just increase it. No problem. And you notice that above certain voltage, we have this warning sign on the UT61E, but not on this ET829. Now that's not a big deal, but just want to point that out. So now let's increase it to the maximum. And you can see that these 2 meters are largely in agreement with the measurement results. Of course, one of the main selling points of this meter is its built-in oscilloscope. So to test that, I have hooked up the output from the signal generator into channel 1. And let's change it to oscilloscope mode. And let's see if we have the arbitrary waveform working. Yeah, it's at 1 volt peak to peak. So let's go back to channel 1, and let's try to acquire the signal here. For that, I'm just going to press the auto. And you can see that we acquired that signal with no problem. So let me zoom out a little bit so we can see the control I will show you here. And to control the oscilloscope actually takes a little bit of use to, but it's quite intuitive. So if you press the channel 1, and you will see that we have this menu, DC coupling, probe is 1-to-1, bandwidth is on, and limit is on. Of course, I can press channel 1 again, and we can go to the next page. And here we have position off. So what a position off is, when the position is off, you press up and down, it will change the input attenuation here, and you press left and right, it will change the time base. So that is quite intuitive. But if you turn on the position, what is going to happen is essentially you can see that if you're pressing the down button, it will shift the waveform down. If you press up, it will shift the waveform up. So that is something you need to pay attention to. And of course, as a digital scope, you can also change the trigger function here, and you simply just press down the trigger menu. You will see we have channel 1, right now it's on rising, you can change it to falling, and that's pretty standard. The mode is auto, single, and normal. So we'll take a look at the single shot capability in just a minute, but that's actually pretty standard. And of course, while you are observing the waveform, you can also press the menu button. You will see that we do have different annunciators you can add onto the screen. For example, volt, and you can do peak-to-peak voltage. Let's do that. And let's see where did it show here. So let's go back. Yep, you can see that right now is peak-to-peak at 2 volts. Now, again, because the font is red, you can't really see it that well, but it's right out there. So let's see here, menu, and let's get rid of that volt. And as you can see, all the basic functionality is essentially there. Here I'm displaying an amplitude modulated signal with a 1 MHz carrier frequency and 10 kHz 100% modulation. As you can see that the signal is fairly stable. And here is a 1 MHz frequency modulated signal with a frequency deviation of 10 kHz. Now I wasn't able to get a stable measurement regardless of the trigger setting, and unfortunately you can see that the signal is jumping all over the place. Also, you'll notice that the waveform update rate is unfortunately very slow here. The slow waveform update rate unfortunately does limit the scope's use. In my opinion, it's probably only suitable for periodical, stable waveforms and not suitable for observing transient and varying signals. And just for completeness, now I'm going to measure the power on characteristics of a switching power supply using the single shot mode. So I set the trigger to single, and now I'm going to turn on the power supply. And you can see that we can capture that waveform with no problem. Now let's try to determine the actual bandwidth of this oscilloscope. For that, I'm using my HP8642B in the background. You can see that it's generating currently a 10 MHz signal. And I'm going to zoom in onto the screen here as it is a little bit difficult to see the red signal on the background here. And you can also see, probably not that well, is we do have a frequency reading of 10 MHz. Now let me increase the frequency gradually and see what we got on the screen here. And if the waveform drops to about 70% of the original waveform height, then we can conclude that is the bandwidth here. So let me increase the frequency here, 20, 30. Let me change horizontal a little bit. So right now we're at 30 megahertz. You can barely read this, but that's just probably the coloring here. And anyway, so let me keep increasing, 40, 50. So you can see that the amplitude is dropping, but some of that is probably due to the imperfect matching of the cable. So we'll take that with a grain of salt. But right now we're roughly at 80%. We will keep increasing, and right now it's 60 megahertz, 70 megahertz. And you can see definitely from 60 megahertz to 70 megahertz, we're dropping significantly here. And that actually roughly is about that 3 dB bandwidth. But let's increase it to 80 megahertz and see what we got here. So 80, and you can see that at 80 megahertz, we are still able to measure the signal, although the amplitude dropped to about 50%. And given the cable loss and so on and so forth, probably the bandwidth is right about there. And I would say maybe 70 megahertz is more like it, or maybe 60 megahertz, but you can see that the drop is fairly gradual. Let me keep increasing the frequency a little bit to see how high we can actually measure the frequency here. So now at 90 megahertz, you can see we dropped further, and here is 100 megahertz. Yeah, we are barely able to measure that signal. So yeah, so I would say 80 megahertz is probably the maximum that you can measure using this oscilloscope reliably. And definitely 70 megahertz, no problem. 60 megahertz, no problem. I would say that 80 megahertz is probably really pushing the maximum frequency, but I will give it that. One thing I forgot to mention while showing you guys the oscilloscope is that it actually doesn't have an XY display capability, so which means you cannot use this oscilloscope to observe Lisa figures. Now let's take a look at the function generator here. And the built-in function generator is actually very rudimentary. It has sinusoidal output, as you can see here, and also it has square wave and ramp signal. That's about it. And the only thing that can change is the frequency on the sinusoidal. For example, let's change it to, let's say, 1 megahertz, and let's do 1, enter. Let's see how we do this. 1 megahertz, and you can see that we indeed can generate that 1 megahertz signal, so no problem at all. And we can also change it to square wave. Now at 1 megahertz, the square wave looks a little bit of rounded. That is also normal as well. What else can we change? Well, we can change the duty cycle. We can't change the duty cycle. It's actually only 50%. Unfortunately, for the square wave, we can see that we can't really change the duty cycle. It is fit at 50%. And also the voltage selection is limited as well. You can see that we can select different voltages, 5 volts peak to peak, 3 volts peak to peak, and so on and so forth. But there's no continuous adjustment of the output amplitude here. So we can choose 2 volts peak to peak. Of course, we have to readjust, and we have to require the signal. And that's actually a pity. Now let's change the frequency back to 1 kilohertz. So we can see the signal a little bit more cleanly here. And let's reacquire that signal. For some reason, oh, I know, because I changed to 1 hertz. Let's go back here again. Square wave and frequency 1. So I want to do 1 kilohertz. 1 kilohertz. That's interesting. It's saying still 1 hertz. Let me just try it again. 1. I think I need to do a 1. That's right. So I did not do the number 1, and now 1 kilohertz. Okay, that is working correctly. Now let me acquire that signal again. And we can go to the ramp signal, and you can see that we can change the frequency. We can also change the output to these discrete preset voltage values. And let's see if we can change the duty cycle. Nope, no duty cycle. So let's go back to the sinusoidal. And for sinusoidal, also the output is only limited to these discrete frequency values. So I don't think you can see that very clearly. Let me just show you here. So you can see that we only have this many voltages to select from. So let's select 5 volts peak to peak. And let's come here. And let's reacquire the signal. So I wouldn't have called this an arbitrary waveform generator, as there's no way you can generate an arbitrary waveform. It is just a really very simple function generator. I don't want to make this video too long, so I will save the teardown for another time when I get around to it. In conclusion, the ET829 scope meter is fairly well built, and it has some rather neat features not found on other scope meters that I had reviewed on this channel before. The bandwidth of the oscilloscope is also decent, and the controls are fairly user-friendly and intuitive as well. Now here are some downsides. The buttons feel a little bit spongy, and sometimes it's hard to tell whether you have pressed down far enough or not. And some measurements using the oscilloscope can be a little bit cumbersome. Also, the scope does not offer XY mode, as I mentioned earlier. The built-in function generator is also somewhat basic and doesn't generate continuous output levels. Leave me a comment below and let me know if there's anything else you want me to test with this ET829. And also let me know what you think about this scope meter. If you liked the video, please give it a big thumbs up and remember to subscribe to the channel. I will catch up with you next time.